My name is Srivatsan, and I've been working on a startup idea for about a year and a half. Well, about a year now. I quit. I was with Microsoft Research as in the machine learning group there, and we did a bunch of basic research in machine learning, data mining. And in May of last year, I quit. The idea of Scibler was a little prior to that. It was sort of, thawing away and gnawing my head. And in May, eventually, I quit to start this exercise. Today, I'll stay out of talking too much about Scibler. I mean, I'm happy to talk about it as we meet, informally. I thought that, I've been doing machine learning is probably the only thing I've done in my professional life, right? So it's now I'm clocking about 14 to 15 years of, building machine learning applications, theoretical aspects, writing theorems, applying it to practice, and making it work for real data and stuff like that, right? So there's a bunch of rules that I have in my head. And today's talk, it might come out a bit preachy in that sense, excuse me for that. But the caveat is that I look at this list of things as, I go to this list every time I start a new project, right? So, take it or leave it. I'm going to start by just quickly telling you about the AI hype cycle. How many of you have heard of this AI hype cycle, right? So basically, the AI hype cycle, back from Alan Turing with his, Turing machine idea, more than 60, 70 years ago, sparked a kind of a continuous effort to make computers behave intelligently, right? And there was a lot of expectation. There were a lot of interesting techniques that were devised. And, somewhere in the mid-80s, people thought that they're going to crack, machine learning. They're going to crack artificial intelligence. And then there was a huge bust, right? Basically, there was a disillusionment. There was lack of ability to monetize ideas that came out of research in machine learning or artificial intelligence. And artificial intelligence essentially died, right? Somewhere in the mid-90s, the advent of, in some sense, the merging of statistics and artificial intelligence and optimization theory allowed a second birth. And, there was, towards the late 90s, you started looking at, you're getting more practical techniques like support vector machines and logistic regressions becoming more popular in real world. And that sort of started, in some sense, a positive slope again. Have we really hit a kind of a profitable, we know how to monetize machine learning? I don't think we are there yet, right? If you just look back, what 2000 to 2010 has done, some great machine learning based products. Google search ads, of course, tops the list. Amazon gives you shopping recommendations, huge data mining problem with, wonderful success. Facebook news feeds are very cleverly organized so that you always want to like them. Pun not intended. Microsoft Xbox Connect, I think it's a remarkable computer vision product. The only consumer-facing computer vision product out there. It's raking in billions of dollars. So 2000 to 2010, a lot of product ideas around machine learning, successfully monetized, successful products out there. Consumers are using it, right? 2010 plus, big data is everywhere. Everyone is talking about big data. Everyone is saying, hey, I want to ride this wave. I don't want to miss this. Everyone wants to attend, grad school and take machine learning courses or big data courses. Everyone wants to know Hadoop and everyone wants to know MySQL, whatever, right? Now, and the applications are across any kind of industry that you name, from marketing, business intelligence to retail, manufacturing, every single sector that's making any money of anywhere in the world is talking about big data, right? And there are estimates that say that nearly 70% of major enterprises would have adopted some kind of big data strategy by the end of the year. It's remarkable, this number. And each of them would be at least spending $8 million a year, right? There is a long tail involved. Some people are investing much more than others, but nevertheless, there's a huge push, and the expectations are very high. But as a machine learning, data mining, data analytics community, are we ready for this yet? I think there are exciting opportunities, but there are acid tests to go. In the next 15 years, if the community cannot deliver return on investments, if the community cannot deliver, really catchy products and services based out of these ideas, we're going to have another disillusionment trough. We're going to have another dip, and everyone's going to walk away saying, hey, that was just hype, right? And the reason why it's an acid test is that very, very difficult wheels in the cog have to work together, right? There's in my mind, three main cogs in the wheel that have to work together. There's the data modeling. Everyone, of course, that's data analytics. You have to model data. So you need to know, you need to know about regression models. You need to know what kinds of techniques are there for classification, clustering, blah, blah, blah. That's the data modeling. There's a lot of math, algorithms, probability theory, stats that's going on in there. There's a lot of engineering. There is, how do you deal with big data? How do you store, process, manipulate, transmit big data efficiently? There's, of course, Google did this big thing about map-reduce based technologies. So there's a lot of progress that we've made in engineering. And even today, in my view, this is the place where there's maximum information out there. Engineering side of these three wheels. This is the place where there is maximum information. This is the place where you have maximum skill. Okay? Domain expertise cannot be understated, but it's the thing that's sorely missing. And it's the biggest risk as we move forward, right? If you have a data analyst who's looking at data, the domain he doesn't understand, you're going to get a disaster, right? And to be able to make all these three things move together synchronously and actually pull through, I think there's a lot of, that's the acid test, right? Because there's no single individual who can do all three, right? And people are coming from different disciplines, extremely cross-disciplinary, and there's this effort going on. In my mind, right, machine learning technology is commoditized, okay? There are open source tools out there. You can, run whatever technology you want, whatever classification method you want, decision trees, C4.5, stubs, whatever. So many techniques are available. You can pick it off the shelf and you can run them. Neural nets, conditional random fields, whatever you want. But problem solving is not commoditized. And that is something that really needs serious investment that requires internalization, right? Lack of domain knowledge, like I said, is I feel the single biggest hurdle, most dangerous hurdle that we may face, right? And when we talk about, whether you're building an enterprise solution or a consumer-facing solution, if you are not talking to the stakeholders, if the stakeholders from the analysis are not involved in designing the model, we are at risk. So I would say if you're working in a large organization like like a Google or Microsoft, whatever, if you're developing a solution for an ad center or a search team, go and sit with them. Spend 6 months, 8 months with them. If you're the data analyst, sit in their meetings, figure out what they're doing, how are they currently solving the problem. Try to figure that out, because otherwise you're not going to solve the problem right. In fact, there is a distinction between building enterprise versus consumer products based on machine learning, right? If you're if you're shooting for an enterprise product, then you need to co-locate with your early adopters, right? And you need to go and figure out how are they solving that problem today? How are they dealing with that same problem? You're saying that intelligence is going to solve this problem. How are they going to solve it, right? And I'll give you an excellent example. A very good friend of mine, he has this startup. It's a startup in the hiring space. He's building a tool that automatically recommends very good candidates for hiring if you give some spec, right? And it's a wonderful tool. There's a bunch of machine learning, text analytics, resume parsing, all kinds of stuff, magic going on in there. Initially, he was not co-located with any of his early adopters. He would always go call them every now and then. When he had a feature update, he would go talk to them and he would come back. and he wasn't getting traction. There was something wrong. There was something falling between. They would say, yeah, these recommendations look good, but I don't know. I don't have time to follow up with these candidates and check if I want to interview them. So eventually he realized that he may have an excellent product, but what he needs is a service. He cannot run this machine learning based product and hope to sell it and make any money out of it. He has to solve the problem using machine learning maybe, but he has to run a hiring service of some sort before something like this can really take off. Building a new consumer product is a completely different beast, and I'm at the receiving end of the stick here, so I don't have successes here. I have lots of failures that I can talk about, right? And what I realized was that, I mean, I participated in many of these exercises where we build things for General Motors, automation tools for General Motors. We build automation tools for pharmaceutical companies, petroleum company, consultancy from within Microsoft, outside of during my PhD as well, and even in Microsoft for core Microsoft products. A lot of things I've done, but when you're trying to build a consumer product from scratch, it's the user-centric design that's the only thing that can tell you what is it that the consumer wants, what is it that the user wants, and it will direct you to the right ML questions. And the reason why I'm talking about this is with machine learning based products or services, you need to pick your battles, okay? Almost 90%, you take any product that you're thinking about, 90% of the problems that you need to solve in that product don't need machine learning. Throw it out of the window. Don't start by saying, I want to apply machine learning to this problem. No. I have a sentiment analysis problem, and something that people were talking about. And that sentiment came out in that sentiment analysis thing as well, that machine learning did not solve it, right? The reason is, that's true. I mean, in general, you don't start off by saying that, hey, I have this product, it's an intelligence product nevertheless. Still, I am not going to try and apply machine learning just across the board for it. I'm going to break this down into sub-problems. I want to give an excellent example from the product that we are currently building in Scibler. We needed a simple technique or machine learning technique, whatever you want, to predict if an email comes from a person or is it coming from a mailing list or a social update, whatever, or it's a bill from a bank, whatever, right? We just needed a way to predict this because there's no exhaustive list of domains that you can have and whatever. And so the obvious thing to do would be ML-based methods, all kinds of complicated features, metadata, headers, information, time of receipt, NLP-based text features, text analysis, all kinds of things, and then a classifier, training data, test data, supervised models, label, classify, everything, right? It did pretty well. But a simple rule solved the problem as well. All we needed to do was, does the user reply to this email address or not? Does the user communicate with this email address? Just asking that one question, we had to just completely stop this. There was no need to build this anymore. This solved the problem. 90% of the time this was right. But this was also right only 90% of the time. Maybe for a different 10%. Yeah?
Maybe it's also, this is the feature you should have selected. Maybe you can also kind of...
This was a feature.
Yeah, so the second point is also...
This was a feature over here. This was a feature over here. That's why we eventually realized that that's the only feature that's having a high weight. So what I'm saying is, see, the point that I'm trying to make here is essentially this. Let's not get into this business of, okay, here's a logistic regression. I can download it. I can sit and eyeball training data plus. These are all minus. Let me run it through the... That's not the way to solve machine learning based systems. That's not the way to build a machine learning product. Understand the nitty-gritty of what the data is about. And like I say, I always tell my team, go to bed with the data. It's the only way for you to really internalize, these are the features that are going to give me the signal. And then sometimes you realize, hey, I really don't need a support vector machine. Why do I need to run 20,000 point convex optimization to solve a problem that I can just do by a string match, right? All I need to know is look up the database. Is the user communicating with this particular contact? If yes, then it is a person. But if a user has been emailing me for the first time, then I will make a mistake. But that's happening only 10% of the time. If at all I want to build a machine learning technique, I should be building it for that 10%, not for the whole thing, right? I just want to, these are, I mean, insights. I don't know whether it's, getting you excited or not, but these are insights that I learned from, I fumbled and, fell and hurt myself before, spent so many weeks building out more complex things to realize, hey, what the hell? I mean, this should have been solved like this.
But then you wouldn't have been sure unless you actually did the entire exercise. So when you had probably done the exercise, you would have probably felt that, the correlation shows that there's only one feature, which is like, a highly weighted feature. And then probably realized that.
So, let me throw it back at you. I did this one thing. I got 90% accuracy. It's more or less good enough. My gut feel is that machine learning technique is also not going to give me much more than 90% accuracy. They may disagree on the points on which they make mistakes. That's not the point. That I agree, right? The places where this will make a mistake and the places where this will make a mistake will be different. But the pragmatic view when I'm building, especially in a startup or even for example, anytime when you're building a product, right, you're working with very tight timelines. In one shot, 90% of the job is done. That's all I want for now. Come back to it if the user is cribbing that, this is not working. But for now, if there's any lean interpretation of a machine learning system, this is it. Look for rules which will crack 90% of the cases. Surprisingly, you will find that rules will crack 90% of the cases. By the way, I have lots of very good friends in Google. Google, a majority, I don't know if is anybody from Google here? No. A majority of Google's magic sauce is a rule-based system, right? And it's not that they are using machine learning, but in corner cases, in specific scenarios, after carefully analyzing that there is a need for it. The other thing that I keep seeing, I mean, a lot of people, now we are not in the accelerator. I was in the Microsoft accelerator for some time before, moving out now, and we are our own office space. Even when I was in Microsoft Research, a lot of product teams would come because they would think of us and Microsoft Research as, as experts in this area. And we were a machine learning group, so we had, 4 or 5 PhDs with, a lot of experience and so on. The single thing that I would always tell them is that it's not that you need to do a lot of math, but there's some basic math that you have to solve. Otherwise, don't try machine learning, right? You have to bite the bullet on some basic math, and that basic math would be understand a few basic things. I've put in, there's like a jargon here. I won't have time to go through all of them in detail, but essentially figure out that most machine learning methods, right, they have performance guarantees. If you look at a support vector machine, it will tell you that on unseen data, on data that it has not seen during training, it will give you an accuracy of 90%, or it will give an accuracy of 95%. And that percentage, 95%, it's a data-driven quantity. The theorem is a data-driven theorem. And it's based on, it's essentially saying the probability of error that a support vector machine will make approaches the sample error that you will see in the training set. So if, on the training set you're getting some accuracy, right, or on a, training set or validation set, whatever you want to call it, right, basically data that is not going, it's not on the field, right, you've collected data, you've annotated it as something as positive and negative examples. On that data, the more and more data you see, if you have seen sufficiently large data, whatever the error that you're getting there, the same error you're going to get on unseen data. So if you think about it for a moment, it's quite remarkable, right? But there are assumptions, and the assumption is that the data, whether it's in the, whether it's in your training, system, or it's unseen data that's in the future, they are drawn from the same distribution. There's a probability distribution. God is actually just making these little examples coming out, boom, boom, boom. They're coming out in an independent manner. One point is coming out independent of the other, and that's the assumption, right? It's not that real world data satisfies these assumptions, right? Concept drifts are very, very common. You train a day, spam, it happens in spam all the time, right? You build a spam classifier, and it runs beautifully. 2 weeks later, suddenly, boom, 60 emails in your spam box for some days morning. Monday morning, you come and see 60 emails in your spam folder. What happened, right? Which are missing your spam. What happened? The concept has drifted, right? Whatever the probability distribution that generated the training set is no longer generating the unseen examples, future examples anymore. You have to make some updates, right? It's not easy to detect. But when you build machine learning systems, you have to be conscious of these things. You have to understand that, okay, if I'm using a logistic regression or support vector machine here, then it's guaranteed to perform well only under these assumptions. So let me keep testing these assumptions. Where is it violating? Can I do simple statistical estimates to see that, hey, you know what? Yesterday, 90% of the data was classified as good, 10% of the data was classified as spam. But today, suddenly, 99% of the data is being classified as good, only 1% is classified as spam. That's very absurd. You should be looking for signals for drift. It's no longer true that what happened to the 8%? Most likely it's actually spam which is wrongly classified. You get the point, right? So being able to detect these things, being conscious of these things, being aware of these things, and making sure that whatever your measurements that you do is takes care of these things is so important for the technology to be successful. And always ask the correct questions first. I mean, this can be true in any area, right? But I'll tell you what the questions are, right? Ask whether you want a classification tool or a hypothesis testing tool. Just to give you a contrast, what you should not ask and what I've seen people constantly do, okay? Should I use naive Bayes or decision trees? Should I use logistic regression or support method? That's wrong. That's not the question to ask. Ask what are the fundamentals of the question. What is the problem at hand? These are all techniques, okay? And I can give you a guarantee that if you answer, tell me, is it a one-class problem or is it a two-class problem? Is it a multi-class problem? Is it a multi-label problem? Right? Is there a clustering component or a pattern discovery component to it? Right? Do I need to use hypothesis testing here? These are the questions that you have to answer. And if you answer these questions correctly, let's say you determine it's a two-class problem. I'll bet my money whether you use logistic regression or support vector machine, you're getting the same answers. Well, plus or minus few percent. It's not going to change your, it's not going to make or break your product. It's not going to make or break your service. I can make the logistic regression talk just as much as support vector machine. As soon as I know the nitty-gritties of whether it's a two-class problem, is it a one-class problem. What I should instead be looking at is, oh, is it possible to generally, people keep asking this. I want to just make this one point about this two-class versus one-class. People keep asking, how I need positive and negative examples for any classification problem. The positive boundary, positive example, is it spam or not spam? It's easy to get examples of what is spam. Okay, every time a user marks something as spam, it is spam. But I don't have an exhaustive bag of all possible non-spams, right? That is the reason why spam classification is typically one class. It's not a two-class problem. I can never know the negative class boundary well, and hence I have to choose techniques that are capable of that. If I did not, then I'll have trouble. You will see that my classifier performance will be quite poor. And here, I think, for me, is the biggest learning. Almost all of the other slides before this, I had learned before. I had fallen before and learnt it before. When I did Scibler, I realized a very interesting point, and I'm going to end. This is the last main point that I'm going to make. Bootstrapped data-driven product, it's just like, building that product from scratch, building it from 0, 0. You don't have any data, you don't have any technique, you don't know what is the machine learning problem, you don't know, what model or technology to use. Building that from scratch is just like building a startup, trying to raise money for a startup, right? And the reason is, you start off with zero data. Nobody, if I had to, if you're in a Microsoft or a Google or an Amazon or a SAP Labs for that matter, you are sitting on data. You're solving a problem for which data is, all I have to do is pick up a phone or send an email. I will get 10 million Hotmail accounts, all the emails for a spam. If I want to build the next world's best spam classifier, I don't need to, but I'm just giving an example, right? It is available to me like that. But if I'm doing it in a startup, I have the sum total of all data I have is 0 bits. I don't have a single annotated data. From there, it's just like I don't have a single pie in a startup. right? I don't have any data, I don't have any money. And I'm trying to build a data-driven product which is going to make money, right? This is a quite ambitious plan. At every stage, there is no magic pill. There is no magic pill to suddenly generate a machine learning product, put it out there, and suddenly it will work for millions of users. Not happening. Just like you cannot become $1 billion company overnight. You have to build the database based on which your data analytics works from scratch. Let's get to 10 users. First, let it solve the problem for the founders. Okay? Collect the founders' data. See if you can get a good accuracy on the founders' data. Build only that much of the machine learning to solve the founders' problems. Okay? Don't try to solve a problem which will suddenly stroke, oh, million users can use this tool. I don't see it happening. Okay? By the way, caveat, the success of this, this is a hypothesis, right? I haven't made any money out of my consumer facing product, so I don't want to make this as a, but I'm just saying that getting to 10 users first, right? Get to your seed round. That's like getting to your whatever, angel investment. And then getting to Series A is like getting to, okay, I'm now going to get a, I'm going to be able to get data from 100,000 users, right? So the parallel between, users, data and money, data is everything. Data is king for any machine learning product, right? So I really see this as a very hard problem, and there are some fantastic techniques to actually address it. And they go under this class called semi-supervised models. Have any of you heard of semi-supervised methods? So essentially, you might have heard of supervised and unsupervised. So supervised is when, you get training labels, you have, everything, this is spam, this is not spam, that kind of thing. Unsupervised is you just have a bunch of emails, nobody told you whether it's spam or not. Somehow the algorithm has to do some clustering and figure it out for itself. Semi-supervised falls in between, as you can expect. And essentially the idea is that you have a large amount of unlabeled data, which is very common nowadays because that's what happens in this web age. Collecting large amount of unlabeled data is easy. Getting labeled data, everything costs money. It takes a lot of sweat to get even one label, right? And small amount of, so semi-supervised methods are beautiful because you can start with a small set of labeled data, large amounts of unlabeled data, and you can get to a slightly bigger set of labeled data, right? And you can keep bootstrapping like that. And there are two techniques, co-training and active learning. I'll just very briefly, just to excite the technically inclined people in the audience, just very briefly, little bit about both. So, one method is called co-training. Basically, the idea is that you take small amount of labeled training data, but you can have orthogonal views of it. Okay, you can look at it from two different, think of it as two different feature sets. There's one feature set X1, another feature set is X2, right? For example, in web classification, web page classification, right? Words that are present in the document, in that web, will constitute X1. And words that are present in documents that link to this document can be in X2. They are orthogonal views, right? They can, each of them independently has a lot of power to tell you about this document. But they are independent, they are orthogonal to each other. If you can construct such carefully, and again to do this you need domain knowledge. Point to be noted. To know what should go into X1 and what to go into X2, you have to fight a battle with the domain experts. Right? Keep asking him, why is this feature related to that? Do you think that is not correlated with this? Do you think I can deduce this from that? You have to ask these questions and somehow make it into two sets, X1 and X2. And then the cool thing is this, you build using features X1. Note, this is not data. These are features, your features. Suppose you have 100 long feature vector, 50 of them will fall into X1, 50 of them into X2, and they are arguably orthogonal. And what you can do is you can train one classifier. L is that small labeled training set that you have. You can train one classifier with the features X1, train another classifier with the features X2. Okay? Then you have unlabeled, lots of unlabeled data in semi-supervised, right? You take those unlabeled data, pass it through F1 and F2, whichever they have high, F1 and F2 will give you high confidence predictions, right? Take them as new training data. add R1 and R2, which is, these are high confidence predictions from F1 and F2 respectively, put them together into L. So now from the unlabeled set, you constructed R1 and R2, appended it to your labeled, small labeled set, keep going like this. Now you have a new set, L plus R1 plus R2, and then what can you do with that? You pass it, you train a new F1 prime and an F2 prime with that. Again, just keep repeating, and there are theoretical guarantees for this. It's quite an amazing thing. This method goes, its co-training is Avrin Blum and I forget the other author, but Avrin Blum, he won the 10-year best paper award for this technique in 2009, and it's very, very, so if people have not looked at co-training in practice, really you should.
So, I'm very new to machine learning. What is some labeled data and unlabeled data?
So every example, right, machine learning will allow you to classify an email as spam or not spam, right? So the label is spam or not spam. Those are the two labels. Positive is spam, negative is not spam.
So here, right? Orthogonal feature, by that means like independent of each other.
Yes, independent of each other. The second technique is called active learning. Again, it's a very simple idea. Suppose all greens are one class and all reds are another class. Suppose I had two choices. I didn't have any labeled data, let's say. I just had only this point space, and one technique I did was randomly pick points from this, gave it to the user and say, hey, give me some examples, positive examples and negative examples. So he gave me some positive examples and some negative examples, the red and the green here. Based on that, I learned a classifier. Everything to the left is green, everything to the right is red, right? This is what would have happened if I did a random sampling from this data set. But if I did active sampling, right, I can get much better. If I did active learning, I can get much better classifier. You can see this classifier is much better than this one. And the whole idea here is that you start with some classifier, okay, and then you carefully, interactively you ask the user for new labels, which are green and which are red, by carefully selecting unlabeled points. And how do you do that? Uncertainty sampling, okay. Where is this particular classifier, where does it feel most uncertain, okay? It feels most uncertain near these boundaries. That's where it is most uncertain. Things which are very far away from it, you can easily measure, it's deep inside, no problem. Things near the boundaries are most uncertain. And those uncertain points, you give it to the user. Ask him to label it. It will be a very small set, right? Do this iteratively and you will get a very good classifier. This is called active sampling. So very, very powerful, very simple techniques actually, but very powerful in practice. So I wanted to just bring this up. I don't want to necessarily summarize. I can stop and take questions if there are any. But if there are 5 things that I will look at as a checklist, it is that, recognize that successful ML is interdisciplinary. You can neither do it in an armchair, nor can you do it without domain experience or understanding, without a good understanding of the mathematical models involved, and without a very powerful engineering team. You cannot build great machine learning applications without these 3 elements. And you have to build, as part of the domain understanding, you have to build a trust with the stakeholders. Exceedingly important. None of my efforts where I have not built sufficient trust with the stakeholders worked. I'll give you one very simple example. When we were with, we were trying to do some fault diagnosis in automobile manufacturing for General Motors. That was a project I did when I was doing my PhD. At that time, basically they wanted to do, from the data logs, they wanted to know where is the root cause of some failure in the plant. Okay, so we're doing some root cause analysis. And then what this technology would do is it will do all kinds of heavy number crunching, and then it will say, hey, this is the machine that is causing the problem, right? Inadvertently, they had given us just codes. Each code will look like X1266. EF something, right? And it has its own interpretation. Only the plant floor manager will know what that code is, right? We did this analysis and we sent off these reports. We used to work in that manner. They would look at the reports and say, yeah, this time it's good, this time it's not good, try tweaking, whatever, something. This was a very loose coupling. Mind you, we did engage with them. This was every week we used to meet them, but it did not work. You know why? Some of the patterns we started throwing out, started pointing questions to the work ethics of the group. Okay? So it was trying to say things like maybe they are taking 15 minutes on either side extra of lunch. That's why the throughput is coming down on Fridays. These kind of things. We didn't know what it was. We were not interpreting it. We were throwing out these answers, right? But it failed. We lost their trust. Okay? And then in the next engagement with General Motors, I actually went and I was with the team there. I was working with the team. And this group failed to engage with us anymore, but we moved to the sheet metal division. And in the sheet metal division, same technology, same techniques, same kind of reports were generated. But I and the plant floor manager sat down and said, okay, these codes will be sent to the machine learning tool. These codes will not be sent. Okay? These things are not meaningful because we know the patterns associated with them. We know that every Friday there is a whatever, you know, there's a slightly longer lunch break, whatever, right? So the point is that unless you can build that relationship with stakeholders, you are never going to get. Machine learning has this sense of magic, and people won't know why is it recommending this or that, and unless they can trust you and trust the technology, you're not going to make a success there. And for consumer startups, just first make sure that you have very good user voice in your team. Somebody should represent the user. The most interesting problems, most difficult problems that we are solving in Scibler today are driven by users, user requests, user saying, and it came out of user testing and based on user experience input. So I'll leave that for a sort of like a casual conversation. I'll tell you what examples of that I won't speak about it. And then the last three are essentially when heuristics works, leave them alone. Don't try to make it fancy. Just leave them alone. They'll work fine. And there are always risks of sampling bias, concept drifts. Make sure you know enough mathematics to understand those concepts. Otherwise, don't step into these kinds of very complicated models. Semi-supervised method is an excellent example of things that you should use. All people who are building machine learning products should be thinking about this. So I'll stop there. I'll take any questions. So small advertisement at the end of the talk. We are hiring in Scibler. We're working on some very exciting things. I haven't told you about it, but I hope you've heard a little bit about what I went through, at least. And if you're interested, if anybody in the audience is interested, who are in working on next generation machine learning based consumer facing product, then it's ambitious, but well, I mean, that's the only thing that you want to try, huh?
What product exactly?
So I didn't want to make this into an advertisement, but I'll say one line about the startup. I'm supposed to be able to say it in one line apparently, but essentially we are trying to build, if we get there, we will, what I would like to believe, the world's first automated to-do list, okay? So you connect your accounts, your calendars, and every day morning there's a contextual list of things that you need to do. You have to send email to someone. We have understood the context. The algorithms have understood the context. We need to respond to a meeting request. It could be a bill that is due or overdue, and all these kind of things, right? Contextually, you might get a, you're trying to plan, you're trying to plan a visit to, official business trip, and just as you're planning, Scibler will tell you that, hey, you know what, your wife is out of town on those weeks. She has sent you an email about it, and we would have sort of figured that out, and we would remind you that it's not a slot that you can use. So you have kids in school and everything that you have to handle. So you have to pick another time. So these are the kinds of, like, basically to give you the context of your day every day in an extremely engaging and interesting manner. That's sort of the ambition, but. We have a product. It's being used by a bit more than 100 users. We're closed beta, and it's it's a Chrome plugin that we're offering these recommendations every day to users. And soon we'll be launching a phone app. And once we have the phone app ready, we'll go out into the market, start grabbing customers, consumers, whatever, right? So that's. So there's a lot of machine learning, text processing, NLP. There's a lot of a lot of time series analysis, you know, all kinds of technologies we use inside Scibler, but only after we try all kinds of dirty rules. Until then, we don't allow any kind, no machine learning is allowed till you show that, you know, the best, easiest rules don't make any sense, or, you know, they give a lot of error.
Hi, I have two quick questions. One question is the code training, whatever you talked about, is it related to something called deep learning? People also communicate the idea that some supervised data and a lot of supervised data, combine them to give a better classification. Is it similar to deep learning?
What is similar to deep learning?
Code training. Code training.
Code training. No. Code training has nothing to do with deep learning. Code training is a technology that came out in about 1998. Deep learning is relatively new, and basically deep learning is now a buzz because of the fact that until now, learning neural networks with a certain number of hidden layers, beyond a certain number of hidden layers, would get computationally difficult, right? Now you can actually build much deeper networks. The computational power that you can throw at these problems is much better, and because of that, you can start folding in a lot of unlabeled data also into deep learning, and it'll automatically do a bunch of clustering and stuff like that. So basically, a very deep learner is a neural network which has multiple hidden layers, previously not computable but currently computable.
Second big question is that whenever you explain your product, it is similar to the Google now you are trying to be.
Google now is a kind of a competitor at some level or the other, but we'd like to believe that there is more to what we are attempting than Google now. Yeah, I can talk about it in person. I mean, I don't.
Sure.
Yeah, sure.
So you got a big data set, you build a solution, and how frequently you will do the optimization?
So you have to keep measuring concept drift. That's the only thing that you can do. I mean, if the concept is not drifting, I don't have to retrain. Magic. But if the concept is drifting, then you have to be training all the time. For example, I know that you know, in commercial search engines, ads are served using machine learning, right? When you type a query, things which are, you know, comes up on the contextual ads that come up on the right hand side are machine learning based, and these models are trained every day because concepts are drifting. What people are searching for, you know, depending upon, at least some aspects of it are shifting every day, you know, depending upon something becoming, you know, seasonal changes. There might be something, you know, there might be something in the news that makes people change. Certain kinds of terms will start coming up more frequently. Just because people are searching Malaysian Airlines now doesn't mean they want to buy tickets, right? I mean, it's a very simple example, right? But that's what Google would have done 1 month ago. No longer, right? Now it will be irritating if you see Malaysian Airlines ads, you know, flight tickets ads if you search for Malaysian Airlines, because the concept has drifted, right? So you need to keep, you know, so depending upon the application, you have to keep tracking what are the, you have to measure whether the concept is drifting or not, and there are very, very good ways to measure it. I mean, if you have a good data scientist in your team, he'll sit and say, hey, these are the measurables. If there is variations in any of these data, you know, statistics, then we can be sure that the concept has drifted. Then you have to retrain.
Yeah, so on the similar line, the question is, so for example, you gave the example of spam, in which the concept was drifted, so the spam filter is no longer working. So, I mean, if I know the true population of spam, or true distribution of spam in versus yesterday, so and if they are different, so is that a good measure of concept?
Yes, I mean, a priori it seems like it's a good measure, but you know, you'll have to look. I mean, nothing, you know, I mean, data rules. So we'll have to see if that's a good measure on a.
I struggle in my own company, like, you know, the classifier did not work after a while.
So you have to see what are the core things. I mean, on a specific case-to-case basis, one can go ahead and look at the analysis. What were the features? You know, have the features become stale, or is the distribution? So maybe, you know, some features are not useful signals anymore, right? As opposed to, in some cases, maybe the data points are now coming from a different region in the feature space and whatever, right? So it depends on the problem. You have to look at the problem and start getting understanding that, okay, I want to measure these and these things. One of the things you would measure in the spam case is, what was the class, you know, percentage of spam to non-spam yesterday, what is the percentage of spam to non-spam today. Maybe I won't do it on a everyday basis. I might do it on a, I'll do a weekly average, like a window, Monday to Friday, whatever, Monday to Sunday, Tuesday to Monday, Wednesday to the, whatever. I'll do a moving window and see after that smoothing, is there still any significant change. Then I might say that, yeah, it needs. But depending on the case, you may have to build it, yeah.
How to understand that there is a concept drift is there?
Yeah, these kinds of measures you have to do. You will have to measure these types of things and figure out whether there is a concept drift or not.
So I just want to add a small.
Sorry, just one sec. You had one question?
Active learning.
Yeah.
Those seem to be more like a modified perceptron. Is that like the same?
Everything, all discriminative models are modified perceptrons. Whether it is logistic regression, support vector machines, neural networks, all of these, in some way or the other, they are modified perceptron. Perceptron was the fundamental idea that created discriminative models. Avrin Bloom, yeah, I mean, it's not a modified, it's not the technology, the technique is not called modified perceptron. The technique is called active learning based on, uncertainty sampling, right?
So I just want to add a small point regarding access to data. So I actually was the engineer at the ML team in Amazon, and I remember, we had access to almost every kind of data in Amazon. You could do all sort of cool stuff, recommendations, and network graphs and stuff like that. But then now that I'm in the real world, where I have no access to data, it's a really, really hard problem to crack. So I would love to hear, something about what you went through in actually trying to get this user data. It's a vicious cycle. You have more data, your recommendations are better.
It's like bootstrapping a startup. Like I had that one slide which said that, when you have zero data and, it's like having zero money, and you're actually building a product, machine learning product. In the other case, you're actually building a company or a startup, right? And there is only, things like semi-supervised methods will give you some headway into it. There is no magic pill, and more than anything else, there are some places where you can access public data sets for this and get away. Most difficult problems, unfortunately, don't have data sets out there, right? If Google is a multi-billion-dollar company, it can be reduced to just $1 million company if you remove its data. The data that it has is what makes it a billion-dollar company, and that's the reason why they can deliver that intelligence. Even if Microsoft throws the best machine learning technologists at search, they cannot get better than Google, because Google has much deeper data for many more years than Microsoft, and they continue to gather more and more data. So you can never catch up.
So the other thing is that we used to buy a lot of data from other people. So now in a startup, you can't even buy data. I can't even go and I can't even get data from anyone. So
your only hope is first convince the founders to pay money for the product, make it useful for the founders, make it useful for the founders' family, founders' nearest friends. Then you will get to 20. Then from there, try to get 100 users somehow. Come and give talks in NASCOM. Maybe you'll get it to 200 users. Then try, goes from stage to stage. Sorry. Okay, I am available until in the evening. So if there's any other questions, you can go one-on-one.